let's look at our problem here. We want to find the area under the curve of this function, x squared. I'm assuming that's the function, x squared, from x equals 0 to x equals 2. Okay, we're going to do it using the limit definition. Okay, let's take a look at our function. And I'm going to start by showing approximations. We can approximate the area by adding up the areas of these rectangles. Okay, so notice for the height of the rectangle, I'm using the right edge of the rectangle. Also notice that as we increase the number of rectangles, the number of divisions, the accuracy improves. We're getting closer and closer. Okay, so we need to think about how we can calculate the area of each rectangle here and then add them up. Okay, I'm just showing here now how we get closer and closer to the real area. And in fact, as n approaches infinity, we will approach the actual area. Well, here's the key statement. Okay. So the area is equal to the limit as n approaches infinity of this sum. The sum is the area of each rectangle. All right. So this first piece, 2 over n, is the width of each rectangle. The 2 is the interval length, right? The interval length is 2. We divide by how many rectangles to get each width. And then we calculate the height by getting the value of the function at this increment. Okay, so if you think of the first rectangle, I is 1, so it's 2 over n. Okay, next one is 4 over n. The final rectangle is going to be 2 times n over n. The n's cancel, so it's going to be f of 2, right? Which is the value of the function at x equals 2. All right, so if we can get this limit, then we can get the area. Now all we have to do is the algebra. Okay, so the function is x squared. So we take our x value and we square it. That's the height. Now I can pull out the constants here, 2 cubed and n cubed. And we have the sum of the square numbers from 1 to n. That should be a formula that you know. And it's the sum of the square numbers from 1 to n. Okay, some further simplifying. Excuse me. We can cancel an n. Then I'm going to multiply out the brackets in the numerator. Should do all this on paper, by the way, and just check your work with this. All right. Now I'm going to swap those denominators. And the right side there now is a fraction, and we can split it into its 3 separate pieces. Which looks like that. There's some n's that cancel, and we can apply the limit now to each of those 3 pieces. So the first piece, the n's cancel, so we just have 2. The next 2, we have n in the denominator. And we're going to have basically something over infinity, which is 0. So when we do the limit, that's what we get for each of those pieces. 2, 0, and 0. And then our final answer. 8 over 3. All right. I hope that was helpful. By the way, you could have used the left edge of the rectangle. And that would be a good exercise to try on your own. Try calculating the height with the left edge, and you should still get the right answer. All right. That's all for now.